Section 1.6 Part C dealt with evaluating expressions for a given or a known value of the variable. The instructions in 61 through 68 say, evaluate the following expressions when x equals 2. So for all of those problems, 61 through 68, we're going to be using the value x equals 2. Question number 62 is 4x plus 3. If x equals 2, then instead of 4 times x plus 3, I can write 4 times 2 plus 3. In the lecture video, I encourage you to rewrite the problem with a blank space before writing the value for the variable in. Let's do this problem that way as well. There's 4x plus 3, but in place of x, I've just left a blank space. Now, since I know that x equals 2, or since I'm asked to use the value x equals 2, I can substitute the value 2 in place of the x. The rest of this problem is just order of operations. I need to do multiplication before I do addition. 4 times 2 is 8, and 8 plus 3 is 11. That's my final answer. In question number 66, I'm given x squared minus 10x plus 25. And I'm asked to evaluate that expression when x equals 2. In other words, find out what its value is if instead of x, I use 2. Replacing x with 2 gives me this. And now I have to use the order of operations to make sure I get the right answer. This is a multiplication, and this is an exponent. If you'll recall, your order of operations is parentheses first, then exponents, then multiplication and division, and then addition and subtraction, left to right. I don't have any parentheses here. Well, I do, but there's nothing inside to do in those parentheses. I could actually have written this problem without the parentheses. 2 squared minus 10 times 2 plus 25. The reason I used parentheses was to make sure that as I replaced each value of x with its given value, I didn't forget something. Sometimes the value given for x is a negative number. And in that case, we need to be careful that we're multiplying a negative times whatever's appropriate. So, doing exponents first gives me 2 squared is 4. Now, technically, I should rewrite this entire problem, and only in the next step should I do the next operation in its order, and that would be multiplication. But let's face it, most of us aren't going to take every single tiny little baby step like this. That's okay, just please be careful that you don't shortchange yourself. All I have left now is addition and subtraction. So going from left to right, 4 minus 20 is negative 16, and negative 16 plus 25 is 9. This is my final answer. The value of the expression x squared minus 10x plus 25 when x is 2 is 9. In question number 70, I have two sets of instructions. The first part says, evaluate the following expressions when x equals negative 5. The expression we're given is 3x plus 4 plus 7x minus 6. Evaluating this expression when x equals negative 5 means replacing the x's with negative 5. Let's rewrite the expression with blank spaces or empty parentheses in place of each x. Recall that 3x means 3 times x. So this is 3 times something, and this is 7 times something. Since x is negative 5, I fill in the parentheses, or the blank spaces, with negative 5. And the rest is down to order of operations. This is a multiplication problem, and this is multiplication. The rest is addition and subtraction. So making sure I do the multiplication first, I get negative 15 plus 4 minus 35 minus 6. Then doing addition and subtraction from left to right, I get negative 15 plus 4, which is negative 11, minus 35 minus 6. Negative 11 minus 35 is negative 46. And negative 46 minus 6 is negative 52. This is my answer for this problem. The thing is, there's another set of instructions. After that attempt, we're supposed to simplify the expression first and check to see that it still has the same value for x equals negative 5 in its simplified form. Let's get rid of all the work that we did here, but leave the original problem and leave the answer. We should end up with the same answer regardless of which approach we take to doing this problem. By simplifying this expression, I mean combine the similar terms. And to do that, I could rewrite the expression using the commutative property of addition. In other words, reversing the order of these two terms. I don't strictly need to do that. I can look at the original problem and say, here are some x's, here are some more x's. Altogether, I have 10 x's. Here are some ones, here are some more ones. If I have $4 and I spend $6, then I'm overdrawn $2. This is the simplified version of this expression. Let's rewrite this expression with empty parentheses or a blank space for x. Then go back and fill in with negative 5. Now I have a multiplication problem and a subtraction problem. So using order of operations and doing multiplication first, I get 10 times negative 5 is negative 50. And negative 50 minus 2 is indeed negative 52. So I did get the same answer. I can plug the value for x into the original expression, or I can simplify it first and plug the value I'm given for x into the simplified version. Either way, I should get the same answer. Question number 74 comes from the next block of problems. The instructions here are evaluate the following expressions when x equals negative 3 and y equals 5. The expression we're given in number 74 is x squared plus 2xy plus y squared. The difference between this and earlier problems is that I have two variables, and each of those variables has a different value. They can have the same value, but if they do, it's quite coincidental. Usually, the values are different. Let's start by rewriting the problem as blank squared plus 2 times blank plus blank squared. I'm going to have to be quite careful that I plug the right value in for each of the variables I'm given. I have to put negative 3 where I saw an x. So negative 3 goes here and here. I have to put 5 where I saw a y. So y equals 5. 5 goes here and here. Now, recalling the order of operations is parentheses first, then exponents, then multiplication and division, and last addition and subtraction. I'm going to look for parentheses where there might be work to do. I have several sets of parentheses, but there's nothing to do inside any given set of parentheses, so I'm pretty much done with that. I've checked it, but there's nothing to do. The next one is exponents. That's this superscript. Squared, or to the second power, means multiply that thing by itself 2 times. In this case, that's going to mean multiply -3 by itself twice, and then add. Now here we have a multiplication. I'm not ready to do multiplication yet, I'm still doing exponents. So I'll come back to that, but I've copied it down so I don't forget. And the last piece is 5 squared, or 5 times itself 2 times. Now I have 3 multiplication problems and 2 addition problems. So I'll do the multiplication first and then go back and do the addition. -3 times -3 is positive 9, because a negative times a negative is a positive. Plus 2 times -3 is -6, and -6 times 5 is -30. Plus 5 times 5 is 25. All that's left now is addition. I could rewrite this as 9 minus 30 plus 25, and there's certainly no harm in doing that. But I can also think of it in terms of 9 plus -30. Either way, you should get 9 minus 30 is -21 plus 25, and that equals 4. Question number 82. If you're paying attention, you'll notice that this used to be 81. I'm not sure how an odd number problem got into my worked examples, but I've changed it. We're going to do question number 82. In this block of problems, the instructions say find the value of b squared minus 4 times a times c for the given values of a, b, and c. Each of the 4 problems in the block has different values of a, b, and c, but they all use this expression, and we're going to plug those values in to this expression regardless of what those values are. In this problem, we're given a equals 1, b equals -6, and c equals 7. So we need to start by rewriting the expression with blank spaces wherever we see a variable. Then we're going to go back and make sure that we get the correct variable into the correct space. This is where a goes. This is where b goes. And this is where c goes. Now that everything's in the right place, the order of operations tells me that I must do this exponent term first. -6 times itself twice. Minus, I'll just write this down so I don't forget. Now I have one multiplication, another multiplication, separated by a minus. So I have to do these multiplication pieces first. 6 times 6 is 36, and a negative times a negative is a positive. Of course, I don't need to write the positive, but don't forget your rules for multiplication of signed numbers. I can drop this minus down, and then 4 times 1 is 4, times 7 is 28. 36 minus 28 is 8. That's my final answer. Last one for this part. Question number 90. The instructions in this block say, find the value of 12x minus 3 for each of the following values of x. So questions 85 and 92 all use this expression, but they use different values of x. For question number 90, the value we're given is 2/3. It's implied that x equals 2/3 is the substitution we're asked to make. 12x means 12 times x. We're going to replace x with the value we're given for x, -3. The value we're given this time is 2/3. Using the commutative property of multiplication, I can reverse the order of these numbers. And then instead of thinking 2/3 times 12, I'm thinking 2/3 of 12. 1/3 of 12 is 4. So 2/3 of 4 is twice as much, 8. 8 minus 3 is 5. And that's my final answer.